Students, in this question we are given that the velocity of a particle is moving along a straight line and it is decreasing linearly with its displacement. So you are given velocity versus displacement curve you are given, and the particle is moving such that its velocity is continuously decreasing at a constant rate with respect to the displacement. So this is how your particle is moving. Now you are asked that initially your speed is 20 meter per second and it approaches to 0 at 30-meter distance. Now you are asked what will be the acceleration of the particle at a distance s is equals to 15 meters. Let's hope that the s is equals to 15 meter mark will be something here. So you are asked what will be the acceleration at that point. Now if we recall, the general expression for acceleration is basically rate of change of velocity per unit time, but we do not have any relation with time here. So what can we do? We can multiply displacement on both sides. It is a valid way to do it. Maths is called correct. Now what can we see? If we see that this ds over dt, what will be? So it is the rate of change of displacement per unit time. And what will we call it? We call it velocity. Okay. And the remaining term will remain simply dv over ds. So there are two ways to represent acceleration. One is rate of change of velocity per unit time, that is the general definition. We can also write it as v times dv by ds. Now dv by ds is simply the slope of velocity versus displacement graph. As simple as that. So if we calculate the slope of this graph, so the slope will be equals to change in velocity upon change in displacement dy over dx, we can write it. So this slope is what? Sir, final velocity minus initial velocity divided by final displacement minus initial displacement. So this is how we write our slope. Final velocity is 0, initial was 20 meter per second, final displacement is 30 and initial was 0. So the slope is we have is minus 2 over 3 per second. Okay, meter per second divided by meter, so the unit value of the slope will be per second. So this is del v by del f. Now we have got this part, that is done. This is velocity. Which velocity are we talking about? Because the velocity is a function of displacement, it is continuously changing. So we have to find velocity at this displacement. At s is equals to 15, we have to calculate the velocity. So we are asked what is the velocity at this point. This value is asked. So we can solve this equation by using simply writing the equation of this slope. So the equation of slope, or we can say line, is basically equals to, we can say v minus 20 is equals to slope times s minus 0, both initial points. Okay, so v minus 20 is equals to minus 2 over 3 s. So we are left at that v will be equals to 20 plus 20 minus 2 by 3 s. Now it is a velocity as a function of displacement. We just have to put the value of s to be 15 meters and we are going to get the velocity at that point. So velocity at s is equals to 15 meter will be written as 20 minus 2 by 3 of 15, that will be cut by 5 times and we are left with 20 minus 10, which is 10 meter per second. So now we just have to put these values in our equation, this equation. So this is our basic equation, that the acceleration is basically rate of change of velocity per unit time, which is can also be written as v times del v over del s. Okay, so we have the value of v, we have the value of del v over del s, just have to put the values. So I am left with that the acceleration is v times del v over del s. V we have calculated at that point at s is equals to 15 meters, the value of velocity is 10 meter per second, times del v by del s is minus 2 by 3. So the acceleration of the particle at that point, acceleration at s is equals to 15 meters, is basically you are having minus 20 by 3 meter per second. So this is my acceleration. So we see that minus 20 by 3, option D, option 4 is my correct answer. Okay, thank you.